Hello guys and welcome back to another episode. We write our kernel from scratch. Last time we've started work on our general purpose heap allocator, and to be very honest, while editing the video I actually thought that some of the choices that we've made were quite overkill, and some of them were disastrous. So especially creating our own allocator interface. That was a bit of both. And since there are only two rules that I believe in any form or discipline of engineering, rule number one, use your product to make the product better. Rule number two, do not be afraid to scrape any number of hours of work to redesign something, especially if it's a foundational thing. So let today be a lesson in identifying and addressing shortcomings. We are going to start over, probably from scratch. Yeah. So I have a few ideas that I'm going to try to explore. But before that, let me just go ahead and just comment out all of these nice things. Actually, we can stop here. Right, so let's go with rule number one. Let's use the thing we are building to know if it's good or bad. So let's write a sample usage for this thing. So let's call this, let's do something like this. Cool. Actually, I think I could just do this. That's cool also. This is a throwaway piece of code. So we want to get, so const heap is basically, yeah, we are already in the module, so that's fine. So here we want const kernel GPA, sure, let's call it that, and this would be allocator. So from this, so we're basically going to call this allocator. The contents of this are going to change. This allocator here will be of type stdmem allocator, and then we are going to just go ahead and do my kernel GPA kernel GPA dot alloc some sort of U64, 10 of those. Sure, why not? Const allocated is some, yeah, let's try that and defer the allocated, or rather the kernel GPA dot free. Sure. This is something we could work with. Oops, allocated. Yeah, okay. This is good. So that means that here, this allocator here will need to do the heavy lifting. Actually, let me just call this allocator 2, because allocator 1 was so good, we rebooted it. And let's try to start from here. So this one is a public function, allocator 2. And it returns just stdmem allocator. We are scraping the custom allocator that we have created for ourselves because it's useless. It's overkill. It's bad design. Yeah, there's a number of things wrong with it. Right, so here, this allocator here will return basically just a pretty basic this. Of course, this one here takes self as a pointer to self. Sure, we don't have self. Let's just make do with this. So this one is that, and this one is a v table, and here we are going to just do this, and we should add, yeah, so we have the usual functions. This one is alloc. I think we can create alloc here. Free is 3. I'm not sure we are going to support resize or remap, so let's just no, actually let's support them. No. So resize is setmem allocator.no resize, and remap is can I do this? setmem.allocator.no remap. Cool. So now we need function alloc takes in something and returns something. Very nice. And function free takes in some other thing and returns that other thing. So let's get those. Whoopsie. So this one here is let's just do that. Cool. Am I missing something? Yes, I am. So if I go here, and I should probably just get rid of this. Cool. For free, I'll do pretty much the same thing here. So let me just do this. Go back here and paste that in. Let's go this way, do that, and that should be okay. Let's call this pointer. Sure, pointer. Cool. And alignment is, of course, setmem mem alignment. Same goes here. That's nice. Cool. So now this one here, we pretty much know what we need to do because let's create our heap. This one would be of type heap, right? And this one here would be const self const. Yeah, sure. Const self. The pointer itself is not going to move, so add this. Actually, let me just do const self is, add this, and this module here. This one is self, and this one is equal to pointer cast of line cast of pointer. Sure. Then we are going to go so const subheaps are self.subheaps. Oh, rather self.heap dot subheaps, or maybe we should maybe this goes like so. Yeah, maybe this just goes like this, and we just go and do something like so. So self.subheaps, and these are doubly linked lists. And actually, this is not what I wanted to do. I want this subheaps iter. So this one is dot iter. Cool. So while subheaps iter dot next, and here we capture subheap. Sure. And here we do if subheap dot can alloc. Let's think about this for a second. Let's think about this. Yeah. Okay, that's cool. That's actually cool. If subheap dot can alloc, then we go ahead and actually we need to pass it length and alignment. That would be a nice thing to do. And if that's the case, then we return subheap dot so let's create an allocator. This is subheap.allocator. And this here would return allocator.alloc. Yeah, now this is okay, no, actually, never mind. I think that's okay. Yeah, I think that's okay. So len and alignment. This might become a problem, but let's see. Of course, this one, I'll just call it alloc. And I guess we already have alloc. Of course, so subheap alloc. How about that? Nice. So here, return address, we probably need to pass that also to this somehow. Now, so here we break out of this loop. The only problem we have is this. But we might be okay. This is basically, if this is a typical allocator, that means that we are going to create this in a loop, basically, which is not great. But we only do that if we can allocate from this current subheap we're looking at. So I would say it's all right. Otherwise, we return null. If we couldn't find any allocation. Right, okay. Now, let me just copy these. That's fine. And here we have memory. We have an address. So const memory start is memory int from pointer of memory.pointer. Sure. And here we are going to go through the subheaps. So subheap iter.next. Capture that as subheap. And of course this would need to be variable, I think, for both of them. Subheaps iter. Cool. So if subheap dot memory start is less than or equal to subheap dot or rather to memory start, and yeah, let's do this here. So subheap mem start is subheap subheap.memory start, and whoops, const subheap mem and is subheap.memory or subheap mem start plus subheap.memory len. Yeah, and memory start let's just call that memory pointer. I didn't rename this. Okay, cool. Memory pointer. Same goes for this. And this one is less than or equal to subheap mem and. Of course, we need to try, rather change this. So if that's the case, we probably want to yeah, just ask that subheap, so subheap dot free that memory with that alignment and return address is what I'm thinking. And of course we return right after that, and here we, well, basically we don't do anything. No, this one here should unreachable. Let's just mark this as unreachable, because if we reach here, that means that we have been asked to free memory that we haven't been haven't allocated. So yeah, kind of weird. Right. So in allocators, in both allocators and in freeze, I think this branch here would be the most or the more likely to be taken. So I'm just going to go and do branch hit likely. Yeah, sure. And just going to do pretty much the same thing here, because it's not like we are going to have 3,000 subheaps. We are going to have 3 of them, 4, maybe 5 at most, and we are going to try to be smart, and every time we fill up a subheap and we need to extend our heap allocator's memory pool, we are going to allocate with some policy that basically doubles or quadruples the memory that we are allocating. So we are going to try to not have too many of these at the same time to optimize allocation. Yeah. So let's mark those branches as likely. Now, with what we have here, we are starting to see what things we need to have. So we just want this subheap to know if it can allocate. We don't really care about its underlying allocator known. All we care about is this subheap here has this can alloc function here. So that means that this subheap here would need to have this public function can alloc, right? That takes a self, which is a pointer to self. Now the problem is that so const self is at this. Right, so this one takes self, it takes a length of type SUSI, okay, usize, and it takes an alignment of type stdmem. Alignment, I think that's pretty much it. Returns a boolean, and I guess that's, yeah, okay, so let me just go ahead and do that. Or no, const subheap. Can I do this? No, I don't think I can. Yeah, let's just go ahead and do this. So subheap here. Now we can do one of two things. We can either have a can alloc function here. We need to specify when we create our subheap, or this allocator here needs to know about the can alloc, but we don't want to create a an allocator interface, our own custom allocator interface. So what we want to do is we want this to be an interface. So interface plus non-generic, right? Non-generic because we want to put all of these subheaps in the same list and not have to worry about the types. And we'd like to have it have the allocator, the stdmem allocator interface, plus have an a can alloc function, right? So these are the bounds that we want this to obey. So let's try to call this allocator wrapper. Sure, let's call it, yeah. All right, we'll come up with a better name in a bit. But so const allocator wrapper. No, let's call it subheap allocator. Yep, that's better. That's much better. So subheap allocator is a struct. Of course, we want this to be non-generic. And this one will have the classic a pointer, which is an any opaque of some sort, or rather a pointer to some opaque type. We want a can alloc obviously, which is a const pointer to a function that takes an any opaque and returns, or rather, it also takes a length, or rather a usize. Let's just do this way, and stdmem alignment, and returns a boolean. And we probably should also, so I'm just thinking about, yeah, that should be fine, I think. So here on this interface here, we'll have a function, can alloc, right? So this one is a public function that takes self, which is a pointer to subheap allocator. Yeah, actually, this might be a better idea than just that. Yeah, that's fine. So subheap allocator takes in a length as a usize and takes in an alignment, which is a stdmem alignment, and returns boolean, of course. And this one here would be very simple. It's going to do self.can, or rather, it's going to return self.can alloc of self.pointer and length, I think, and alignment is what we called that. Yeah, cool. And then it's going to return public function allocator. Again, self pointer to subheap allocator, and this one returns stdmem allocator. Nice. And then this one should return. Now, what is this one returning? Actually, maybe we should do something like this also. Allocator. Create allocator. Sure. This one is const function that takes a generic type and returns a stdmem allocator. So that this one here does return self.create allocator of self.pointer. Yeah. Okay. We can go ahead and see if this is fulfilling our needs, but for now let's just crack on. Right, so in this can alloc we do, so this one is self.can alloc, we do self.allocator.can alloc, of course, of len and alignment, and we return that. And then, of course, here public function allocator. This one also takes a self, which is a pointer to a subheap, returns a stdmem allocator, and we just forward the call to self dot. Okay, well, this one is alloc. Sure. So does this one. So self dot alloc dot allocator. Yeah, okay. So now this here will be bound to that allocator. This here will be bound to can alloc. This alloc here, this one here would be of type, so let's just type hinted here, allocator. Now, this one here has a problem, so we should probably go for row alloc on this one here, and we should probably go for row free on this one here. Oh no, hold on 1 second. We need an allocator here, and then we do subheap alloc dot row free, and this takes memory, alignment, and ret address. Okay. Now this is looking promising. Okay, So I'm just going to go ahead and make this the king allocator here, and we're just going to go ahead and go here and do we can get rid of this, I think. If we delete this, we are not going to be able to build our kernel. No, it's fine. It's fine. We're just going to jump straight into the deep end here. Right, so now the only problem we have is how do we create a subheap? So to create a subheap, so let's go ahead and do public function. Okay, let's actually use this. So this one is for our usage code. We are going to do my heap module.allocator, and this one is going to return an allocator. This heap module is just a constant. We will have a so here we have the heap module, but we are going to also have in memory somewhere here just an instance of so const GPA, GPT, not GPT, GPA. And this one will be something like heap dot, and we are going to create it, our heap here, so that we can just do import memory and then GPA and use that. Right, so that's fine. Now, how do we actually go about adding subheaps to our list? So first of all, we want this to work with any allocator, the subheap here, not just our body allocators. So let's go ahead and use some other allocator that's not ours. So let me just go ahead and create a buffer here. This one will be a sort of yeah, sure, let's go U8 this, and let's create 256 of those. Here we are going to go ahead and create fixed buffer alloc, fixed buffer, sure, and this one is the heap fixed buffer allocator dot init, and takes in a buffer, and here const fixed buffer alloc is so thinking yeah, so now let's actually do this fixed buffer subheap. Now this one here would need to be of type subheap, obviously, and it's going to need to have so .alloc, and this one here would need to be of type whatever we called that, and here we need a memory start, which is at int from pointer of buffer, whoops, and memory len, which is buffer.len, sure. Just do this. Of course, we forgot this, and of course, we forgot this. Nice. So here we want a pointer is a pointer to fixed buffer. Let's just create these manually for now. Can alloc. Can alloc here. I'm just going to go for can alloc true. And I'm just going to create a, yeah, let's just create here function can alloc true that takes in a pointer, which, or rather, let's just discard those. So any opaque, some usize, okay, and some submem alignment int and returns bool, and then returns true. Okay, and create allocator Now this one is the hard part. So this one is stud mem. Yeah, so this one is kind of hard because we don't have we have a function that creates allocators in our how do I go about this? In our subheap allocator, we have this function that creates an allocator, but this one takes any opaque. Whereas the function that we have in our subheap allocator is, or rather in our fixed buffer allocator, takes a pointer to t. So yeah, that's the problem. Now, we can probably dance around the problem by creating some sort of function allocator adapter. Again, same thing here. So this one takes a t, which is a type, and it basically returns a subheap allocator. No, it returns a type. Sure. So let's think about how this goes. It returns a type, and we just go ahead and return a struct. This struct here has a so thinking about this, it should have a pointer to t. So pointer is a pointer to t, or rather, and the allocator here is pointer to t, and we should probably do pub fn init that takes in basically alloc, which is also a pointer to t, takes in should we also go for the full thing, so with can alloc and stuff like that? We'll see. So this one returns this, and this returns return something like, so alloc is alloc, and here we have one other public function, which is allocator, that basically returns a subheap allocator. Yeah. So subheap allocator is our interface, our non-generic interface here. Cool. Yeah. Okay. That sounds good. That sounds pretty hype. Right. So this one here returns this. So pointer is pointer is of course this one here would need a self with a pointer to this, of course. So this one is self dot t, or dot alloc, sure, and can alloc is we probably need to take in a can alloc. Sure, let's do this here. Can alloc, just as a function here that takes in an any opaque, a pointer, any opaque, a length, u size, sure, and size, and an alignment of type stdmem alignment, and returns a boolean. For now, let's just do return. How do we go about this? This one can now become can alloc, right? And create allocator will be create hold on, let me think. So create allocator will be yeah, let's do create allocator here. So let me just copy this over here. This one becomes create allocator. And do this. And this one obviously does not return that, returns the mem allocator. Doesn't need this, doesn't need this, that's fine. What is the problem with this? This has a problem there, and then this has a problem here. Okay. Right, and this one here probably needs something. Okay, that's fine. Do we have other problems? Yes, of course. Let's get rid of that. Nice, and this one has here. Very cool. We still have another problem. Yeah, okay, so we do have quite a few problems. Let's move on. Let's move on. So can alloc. This one here takes a pointer to any opaque and should call can alloc on whatever. And this one here will do. So let me think about this. Let's actually take some arguments here, which are going to be struct of can alloc, and this will be some thinking. Let's create a const can alloc function, which would be a pointer to const function that takes in an any. No, this one would be able to take in just a pointer to t actually, which is pretty cool. So pointer to t, usize, and studmem dot alignment, and return boolean. Okay, so this one here would be of type can alloc function. And we probably might want this to be optional and give it a default value of null, because we might already have a function that's called can alloc in our allocator, especially the body allocator. So I don't think we need to jump through hoops for that one. We just need to actually tell it to just hook the can alloc function from that. Right, so this one here would take const self. This one would become a pointer to t, and of course we are going to pointer cast and align cast that pointer. Okay, and then we do self dot. No, so thinking. So yeah, if of course here we need to get these arguments here. So can alloc is args dot can alloc, of course. So this one here becomes can alloc, and this is an option to a can alloc function. So if right, so now this is problematic. So probably this goes like so. Yeah, this probably goes like this. So if self dot can alloc, and let's just capture that as CA, we should do CA on self.alloc with length and alignment, and of course return that. Yes, okay. Else we are going to so we probably don't need to do this here. We can do this here. So const can alloc function is either if args dot can alloc, capture that as CA, and here we are going to create f block with this. And so thinking, no, actually that's not the best way to go about this, I think. So let me create the block here. Yeah, let's just create the block right over here. Do this, probably go ahead and do this. Right, cool. So if that, we break block with CA, else we break the block with t.canAlloc. Okay, that sounds about okay. So this one becomes canAlloc function, and that means that here we basically can avoid doing any of this by just calling self.canAlloc to self.alloc, yes, and len and alignment. Sure, and of course return that result. I'm not sure that this is going to work, at least not 100%, but we are going to roll with it for now. So now this one here, I'm just going to get this pointer cast here, and we are going to return self.alloc.allocator. So here we don't need to know anything about this, because this will ensure at comp time that this type T has an alloc function or an allocator function. If it doesn't, then it's not an allocator. So that does the check for us. Right, we could probably here, we could probably do a comp time block and do if has decal. Yeah, we can do if has decal, the container is T, and we can say allocator here, and if it's not there, we can do something like at compile time error and something like type. Yeah, I guess T is not an allocator. Sure, it could work. But actually, I don't need to do that, because this is all comp time. Yeah. Right, so now let's go back here. So we are going to, first of all, create fixed buffer adapter, or wrapper, I think we called that. Oh, no. So this one is allocator adapter, so we call it adapter. Cool. So let's do adapter. So this one here, I guess we have an init function on this, so let me just use that. And of course it needs a type, so instead heap fixed buffer allocator.init. And this one takes a pointer to fixed buffer, and it takes as arguments a canAlloc, which we are going to just set as canAlloc true. Right, this is this might look like it's a lot, but it's actually fine. It is actually fine. Let's actually do something here. Const adapted allocator, and this is allocator adapter of type of, is that something we can work with? Fixed buffer, I think. And then this here becomes adapted allocator. Yeah, okay, cool. So this now becomes .alloc is fixed buffer adapter .allocator. Wait, yeah. Yeah, probably not the best name. Subheap subheap allocator. Sure. Subheap allocator. Cool. Now that we got here, we might as well try to do something on our allocator here. So we want if fixed buffer subheap.can alloc for some size. Let's go for 128 with an alignment of, let's go for 1632. Yeah, sure, something that's a bit wild. Then fixed buffer subheap.alloc .allocator. Of course, this goes here, so alloc is that, and of course this one is not used, so alloc alloc type u64. So let's go for a size of u64 times 10, sure, u64, 10 of those. Try that and give me the allocation. So allocation is that. Of course, we defer alloc.free allocation, because why not? And what is the problem with this guy? We shadow a something else that's called alloc. Subheap alloc. How about that? All right. Cool. So now we have working. We have a skeleton of some code that looks fairly sane. I guess we could say it that way. Now let's go here and try to fix the problem. So this one is called alloc by shadows. Some other thing that's called alloc. Probably this one here. This one is supposed to be a not a public function, so I'm just going to change that to what is yeah, okay, bro. Not worry about that. Right, so let's do this. Now it should free the keyword or the word alloc, and we should not have any problems here on this file anymore. Right, so maybe should we run a build and see how this goes? Am I happy with the progress? I can't tell yet, but let's go ahead and run a build. So go back and do zig build test. Okay, so what is the problem here? We don't have a priv and the next in subheap for some reason. So hold on. Yeah, of course. So this one we need a priv, which is an option of a pointer to a subheap. Of course, we're just going to init that with that, and then here we have the same, so subheap, which is also auto init to null. Expected 1 argument but found 0. Where is that? Oh, here. Expected 1 argument but found 0. Right, okay, so Yeah, so const GPA. No, let's call this kernel GPA. And then this one is so self, and this one takes subheaps, which is just that. And it takes, hold on, let me just do this first. And it takes in total allocated memory, which is, yeah, that's fine. And then this one is kernel GPA allocator. This one is kernel GPA dot allocator. And of course, this one here has allocator all over it. And this one also does allocator. Okay, so expect type pointer to heap, but found const heap. That's fine because this one here needs to be a variable. All right, hold on. Let me just clear this up and look at this. Expect type pointer to const function that takes in a pointer to heap thing, but found a const function that takes in a pointer to an any opaque. Okay, right. I see what the problem is. That's 218. That's about here. Okay, so let's make this more complicated. So make fake can alloc, right? So this one takes in a comp time t, which is a sort of type, and it returns a pointer to const function that takes in a pointer to t, a usize, and a sed mem alignment. And the boolean, of course, because why the hell not? Right, so this one, whoops, this one goes, this one comes here, this one gets surrounded by a struct, because no function can be left floating here, and then this one just going to call it f. Right, so this one here takes in a pointer to t, usize, whatever, and returns that. Now, this one here becomes make fake can alloc with type of fixed buffer. Sure. How about that? Root source file struct has no member named can alloc. Now, that's not the real problem. The real problem is why did we go here, where this should actually have been where we went. Why did we skip this one here? Did I not provide it in the init? I thought I did. Yeah, I did. So this one here would return a function, and we use that function. So what is your problem, brother? Wait, hold on. What was that? 181. Is it because we are in the same block and it does some weird shit? Right, so if args.can alloc capture that as CA and create the block just right here, and then this else thing here goes after this, and then this one here goes and this one here goes, and this one just becomes this. How about this? Has no member T, can alloc. It's kind of weird. have thought that this would choose either one, but I think I guess we could flip this around. I guess we could make this a comp time thing by just doing const can alloc function is if has decal what is it, t, and the declaration is can alloc. Sure, if it does have that, then we use that. Hold on, let me just do this. If it does have that, then we break block with t dot can alloc. Else we return break block with args.canalloc. Sure. And obviously this one here needs a block around it, and that and this here needs to equal block. And we could get rid of this. How about this? Okay, cannot call optional type. Yeah, of course. Of course. There we go. How about that? Expected type pointer to subheap but found, so that's 232. I think that's our test code, and that's because the subheap is const, of course. So far there. All right, let's see. Okay, so now the test fails, but that's because we have a out of memory failure because we are asking it to allocate. So what are we asking it to allocate? We are asking it to allocate 80 bytes on a 32 alignment. Let's go for something insane, okay? Of U64. Let's just ask it for natural alignment. Actually, no, that's not why it fails. That is not why it fails. The reason why it fails is because we probably don't have enough memory here. So if we ask for just one, wow, it still fails. Wait, 290. Where is that? Hold on. Let's clear this. Do this. If reference trace is 10. Okay, so we don't have any more than what we currently have. All we know is that it's in 163. Oh, that's actually fine. That's actually fine. Because this guy has no allocations. It has no subheaps. So it's just going to go here, go down to return null. And let's actually prove that by doing stat debug print can allocate. Yeah, that's fine. And do something like this. So if we go ahead and do this again, we should see can't allocate. Yeah, all right, fine, that's cool. So let's just do this for now. I'm just gonna get rid of that, and that passes. So that means that this code here actually works. Let me just go back to what we had here before. So at 32, and we're just going to ask for one of these. I think it should be doable. That's about 80 bytes. Yeah. Let's go for something else here. 120, 128. Can we go for 128? Or is that not known? It's not known. So from byte units 128, let's go. Oh. Obviously, it's because we ask it to check the allocation and we always return true. That's nice. That's very nice. So let's actually call for aligned alloc. So this one is the type and the alignment and the n. So this one here should be alignment and this one here should be from byte units of 129, 128. Cool. So let's see here. Wow, it still works. Oh yeah, because our buffer here. So let's do something like this. There we go. Okay, so this one does not work because we cannot possibly align 10 U64s on a 128 boundary with a 128 buffer that has an alignment of 1, because this one basically has an alignment of 1. But I think if we do align, so is this how we should do this? No, probably here. Whoops. This is, no, oh yeah, okay, hold on a minute. This is how you specify the alignment. So this one would be a 128 U8 line 128. And I think with this, it should be able to allocate it because the alignment, yeah, there we go. Just align naturally. Okay. Very nice. This works. This actually works. Now we have a next problem. The next problem to tackle is actually, hold on. Before we go any further, just going to do a bit of cleanup. So this one goes, this one stays. And I'm just going to go ahead and go to memory allocator and just remove this stain of shame. And I'm just going to go here, allocator here. There's no allocator here. And of course, this will create a problem. We're going to go for stdmem allocator. This one disappears. This one goes to stdmem allocator.noResize, so does this one. Okay. Probably in memory.zeg we have allocator. There's no allocator, brother. I'm not sure where you heard about that, but there is no allocator. Right, so now, let's do the same thing here. Before we move on, let's just try it with our very own body allocator. And actually, before we go, yeah, sure. Let's call it friend. This friend is body.body. That takes in a sort of config here. And this config would need a memory start that we should probably set to something like this, because otherwise it's going to complain. Or does it? Where is this used? Is this ever used somewhere where we need to make it a pointer or something? Memory start. Yeah, start pointer as memory. No, actually no. Wait, hold on, why? Okay. Why are we casting that if it's U64? Right, so let's go for this. And let's go for, I guess that's all we care about. Hold on, let me just give this a check again. Min size, I'm just going to set to 1, because why the hell not? Memory length, sure, we can set that. Memory length is 128, sure. And this one here is just type, and of course here we need to let's rename this from fixed buffer to underlying allocator. Sure. The rest should just work. The rest of the code should just work, except that this line here will disappear because we have a can, or we want to have a can allocate on our buffer. So actually, instead of calling this friend, I'm just going to call it allocator type, so that this goes like so, and we can just exchange them if need be. So try that. No, actually, I would like to test init. This one would let me set int from pointer of address of buffer. Yeah. Yep, okay, pretty happy with that. Let's move on. And now I think I might want to give this test subheap with fixed buffer allocator. Just bring that here. And this one here with body allocator. Cool. So let's run this again, and of course this time it's going to complain. No member of field allocator in mem allocator. Body is not marked as Bob. Okay, let's address that first. Is that here? Kind of weird, but okay. So expected type mem allocator found pointer to. Oh, I see what the problem is. Right. So let's go back here. Get rid of that, and this one here need an allocator actually. It needs a set testing allocator, and we can get rid of the little pointer there. All right. So expected 2 arguments found 1. Adapted allocator, of course, this one here just becomes that. Okay, what other problems are there? In body 725, in body 725, oh, okay. Yeah, because we have changed the way this works. So this one alloc is, this one becomes body.can alloc, and then this one stays the same. This one becomes body.can alloc. This one becomes body, but we don't have can aligned alloc, so we can just do can alloc. And the thing we should do is, this stays the same, that's okay. This one also just becomes can alloc, and then this one becomes body. Right, so from byte units 1, that's fine. How about this? No field or member, so 725. Again, can alloc. Wait, what? There's no can alloc. Oh, I see what the problem is. Is it because we call it can alloc like so? Right, so can alloc. This one takes a self, a pointer to self. We get rid of this. And this goes up somewhere here. Okay. How about this? So expected type use size, but found type in can alloc, of course. So whoops. So 724. This one becomes a can alloc. Yeah, of course. This one becomes a size of U8. This one becomes a size of U64. Can alloc. This one also becomes size of U64 and aligned alloc. Is there another can alloc? Yep. Size of U64. There we go. How about this? Still found expected mem type alignment, but found a oh, I see. So this one is times 128, and the alignment is of U8. Okay, this is kind of bad, but it's okay. So of U64. Wait, hold on a minute. This is the alignment. This is the number of things. Okay, cool. The other one has n being n is 1, and this is the alignment. All right. Okay. Quite a few less errors here. No field or member named allocator in mem allocator. You know what? I'm gonna need that reference tracing. So memory. So 692. Oh. Right. So this one becomes buddy, not Buffy. Buddy. How about that? Okay. Okay. It's attempt to use a null value. Well, that's bad for a number of reasons, but why do we have a null value here? Does this not work? It has decal. How do we go about this? So what is our type? Actually, wait, hold on a minute. Has decal, does that... it's for all declarations? Or is it just for fields that are declared? Has field... Yeah, no, has decal. I expect this to also work for functions. Sure. So, do we have a problem here? So let me do something here. I am going to... Whoops, no. I'm going to change all of this to become just const can alloc function is t dot can alloc. Just going to check something. And of course, this args. And also, I'm going to have to do something like this just to avoid that complaining. Is not marked as public. Okay, that's actually fair. Can alloc. Come on, can alloc. Right, so this one becomes public. Expected optional type, but found a function. Okay. I'm not sure what the problem is. Oh, I see what the problem is. No, not this one. It's in this one. It's just that we'd like this to become less optional. They try to... Okay, so incorrect alignment. That's promising. That means that we went through and we tried to allocate or something. That's actually fine. Now, actually, hold on. Let me just check where this error came from. So 216, just when we try to allocate, so 216, we try to allocate this here from a boundary of this. Why is this not allowing us to allocate it? Okay, this might be a problem with our body allocator, so we might look into that in a bit. But for now, let's fix our problem with this has-decal debuckle. So let's do something like this. Yeah, actually, hold on. Let's do can alloc function is. Can we do actually something like this? Or else t dot can alloc. Is this something that's... Whoops, no. Is this something that's going to work for us? Well, it looks like it does work. Let me just bring this back. If this still goes through, then has no member can alloc. No. Yeah, we have a problem, probably. Yeah, I would have loved this to just work, but it doesn't, so I'm just probably going to leave that for another day. Because what we wanted to have is just be able to pass the type, and the type would make it so that if it has that declaration there. Actually, let me do something here. If has decal t can alloc do at compile time error something like what, and here we just go ahead and yeah, do whatever. So referenced by body allocator or other test with body allocator to okay, so it does work. So why yeah, I'm not sure why this can alloc function is this. I'm not sure why it did not want to work before. Okay, let me just get rid of this and replace it with just t.alloc, can alloc. And of course we need to break whatever block we're in with that. And of course we find that, and that's what our block is. Huh. No, not okay. This one here still suffers from... Wait. No. Now it... Okay, so both of them do compile now. Okay, so this one here, the first one here, goes out of mem because we have the case that we've tried before. Now that one is fixed, so now let's just take a look at the second one. So this one here still fails for some reason. And the reason why it fails is because it's telling us that it can allocate the new 64s with an alignment of 128, which is obviously wrong. So let's take a look at that. Can alloc. Let's just go ahead and do the debug or print. Can alloc D and D. And let's do something like so. This one here would be length. This one here would be alignment to byte units. So I guess I need this one. So that, and of course, I'm just going to, this doesn't exist, so requested length. Yeah, actually, let's add another one there. Aligned length. Yeah, this one. So this one requested length. This one is length, and then that's aligned byte units. Okay, and now I just need to figure out set.debug.print. Yes. Of course, this takes that. Too few arguments. What? One. Where the length? Oh, yeah, this one moved. It's fine. All right, let's see. So 80, 128, 128. The answer is yes. Hold on a minute. Yeah, I think that our computation here fails for some reason. Because if I also add, so mem, and here I'm just going to do something like this. Yeah, sure, something like that. And here go ahead and do self.memory start. Whoops. So if I do that, this one is not 128 bytes aligned. It just isn't 128 bytes aligned. Okay, so I think that this is a shortcoming of how we compute the alignment for the body allocator. Actually, we have an implicit postulate here, which is that our buffer, the memory we are going to allocate from, will always be page aligned. So since here in this case that that postulate does not hold up, or is not upheld, then well, basically we are failing because we try to allocate 128 bytes, which we can do, but since we are not 4K aligned, 128 bytes is not a natural alignment we can allocate. So let's try to play around that by just doing something like this. I think I forgot here to put in U8. So this should work a bit better, I think. So let's go again. Yeah, so now we have quite a few allocations. And this one here leaked. What did it leak? It leaked a node creation. Oh, is it because we have never ever deferred underline allocator.dinit, for example? Can that be the case? I think it can be the case. Right. So let's go ahead and do this. With this now, we have, I'd still want to just be safe, okay? To do check that the memory start is page aligned. Very important to, let me just go back here. Very important because we have an implicit postulate that all alignments below 4K are achievable. By aligning the allocated size, if that makes sense. And this would be fairly easy to do. We just need to go ahead to the init somewhere here and go ahead and do if our memory start is not page aligned, then we cry sad sad cry sad sad. So I think we can do that. Comp time if we can do that fairly easily. If stud mem dot alignment dot do we have page alignment here? We don't. So of no, not of, so from byte units, sure. For 96 dot check, yeah, memory start, or rather if not, check, does check return a bool? Yes. Add compile, no, panic, expected page aligned memory. Okay, let's try this again. Whoops, unable to resolve comp time value. Okay, so maybe it's not a comp time thing. It's the other one that's comp time. The yeah, this config here is comp time, but I think that's something we need to address also. Alright, so that works, and if we go back here and we just remove this, let's do something like so. Cool, very nice. So now we are protected. We feel safe. Right, so now let's also address this here. Since we are going to construct our body allocators at runtime, these two things here should probably go. Yeah. So So I'm just going to go ahead and do that. Let me just add a to-do. So move memory start length to runtime and adapt everything else. Sure. This one, let's clean up a bit. This one was done. This one is okay. Comtime config as input. Yes, but memory we can allocate. Sure. I think. Does this run? It does. Cool. So, does that mean that our heap allocator is done? No, it does not. We still need a way. So let's clean things up a bit. This make fake alloc can go because we would like to have adapted allocators here. In memory, can we actually have something like adapted allocators? Maybe it's too soon. Too soon, maybe. So I want to have something like no, actually, you know what? It's not too soon. Let's go allocator.zig. Yeah, okay, that's fine. We'll find a better name for this in a bit. But here I want to pull this thing here. And go here and do public function fixed heap allocator. Yeah, sure. Let's go for something like this. Hold on, let me just do this. That's a lot better. And here we want this to hold on, let me just pull in stud. This one is import stud here. This one will return a allocator adapter. So maybe we pull that also to the other thing here. So put that here. Can we probably just get rid of... No, we need that comp time t there. Okay, so this one would want to have allocator adapter of stud heap fixed buffer allocator. Okay, so here we so adapt fixed buffer allocator, and then this one here is fixed buffer, which is a pointer to stud heap fixed buffer allocator. Right, and now since we have this here, we can create a fixed buffer allocator can alloc, the real one this time. So this one here goes like, we don't really need any of these. We can go ahead and do fixed buffer allocator can alloc. Okay. Right, so what does this take? It takes a self, which is a pointer to stud heap fixed buffer allocator, takes in a length of use size, and takes in an alignment of studmem alignment. Okay, now let's actually take a look at what this how this decides if it can allocate or not. So it gets an alignment. It adjusts the offset the current and offset. So this is the pointer that points to the end of the allocated portion of the buffer, and it aligns that to this alignment here. I guess forward. I guess there's only one way to go, and that's forwards. Yeah. And then we compute the new and index by adding that adjustment offset, the number of bytes we need to move forward. The new index is that adjusted offset plus the size, and if the size goes over the buffer length, we cannot allocate. Otherwise, we can always allocate. So I guess that's fairly simple. Let's just yonkies these things here. Adds the mem. Add length here. Return. No. Whoops. Do something like this, and here return that this is less than or equal to the other one. If it is, then if this is true, we can allocate. If it's not, we can't allocate. We just need to also address this. This one here is false. We cannot allocate if that's true, or if that's if that cannot be done. Okay, so this one here, we return the fixed buffer allocator adapter. Here we don't need this. Local variable is never mutated, so const. Actually, never mind. We can just go ahead and do return here. Get rid of this. Cool. Subheap allocator. So let's move that also to here. Heap subheap allocator. So subheap allocator. We can move that to memory allocator. Sure. If we go back here, this one now needs to come from allocator, which is good because now we can do allocator hold on, let me think for a bit. So memory, sure, but this one becomes allocator. This one here becomes allocator like so. And here we go to memory and do pop const. Allocator is at import memory allocator.zig. Yeah. Just also going to go ahead and do pub on the both of these because why not? Oh, okay, that's not good. Let's call this mem. Allocator. Sure, you know what? Sure. Mem dot subheap allocator. Let's go to the next one. Bad style. Yeah, bro. Okay. Just show me the errors, please. Mem dot that. And this one. No, actually, this one here goes and is replaced by. So all of this goes and gets replaced by var. Yeah, so let me do this. Var fixed buffer adapter is mem dot adapt fixed buffer allocator, which takes in fixed buffer. And this will give us a free test if it works. Cool. Now, probably do the same thing here for memory. No, not memory, memory allocator. Do the same thing here for Bob adapt body allocator, which takes in a body. Now, this is problematic. Well, sort of, because body will have a generic configuration attached to it. So comp time t type body, which is a pointer to t, sure, and this one is allocator adapter of t, sure, and here we can go ahead to heap and just yank this. I think it's all we are going to need. Yeah. Right, so we can get rid of that. We can get rid of, so here we have a T, sure, and this one is body. And we don't need a pointer because it's already a pointer. And of course, this here becomes a return statement. Okay, so let's go back here. Also adapt. So fixed, let's call this body adapter, which is mem.adapt body allocator, which is has type allocator type and has underlying allocator, probably with a as a pointer, and yeah, this one here becomes body adapter. Sure, let's try this. Hopefully it's not too bad. Few things to mark as public. This one, for example, and this one. Expect struct enum union or opaque. But found pointer. Oh, I see. I see. So 72. This one here is a okay. Actually, what are we doing? We already know what this type is. Okay. We already know what that type is. The only problem is this one, and this one we already have the T in there. Okay, cool. That's still pass. We are golden. We are golden. So this one is fixed. This one should be okay. Body is well, it's doing as well as it can. Now we have danced all around the problem, but we still haven't created anything to actually extend this allocator with subheaps. So let's address that first. But before that, I was actually in the process of cleaning up a few things. So subheap goes there. Yeah, so let me just mark this as a to-do. Self is this. To-do build and allocation tracking. Yeah, this one probably going to stay here for a while. private functions, no one cares. So they go after the public ones, because no one reads those. Tests, yeah, no one cares about those either. Right, so now, public function extend self pointer to, I guess this one here should become self. Yeah, so pointer to self, and as well as memory, which is a slice of U8, and returns void, or not sure if it can error, but yeah, sure, I think it can error. Well, we'll see. So internally, we are going to need to allocate a few things. So alloc will be a permanent allocator here. First thing we need to do is we need to create a subheap, and it cannot just be created on the stack. We need it to be somewhere in memory. So create the subheap. So vars const, yeah, just const. Subheap is alloc.create subheap. Well, that's pretty much all we need with a try here. So this is a pointer to subheap. So subheap, we deref that, and we try to initialize this with memory start is memory.pointer. We need to get an int from that. So int from ptr. Memory length is memory.length, and alloc. Alloc is let's go for adapt body allocator, and that means that we also need to create const body is try alloc.create, not create body.body, and this is where the problems start. So let's go ahead and define something here. Let's call it friend allocator, and this here is body.body with a sort of defaulted config. So the only problem is that now we can see where these things start to go bad. So this one here needs these two parameters. So I'm just going to set undefined. Okay. So yeah, I'm going to create friend allocator. Now that's the problem we have. Now we need to also do body dot that is dot init with a permanent allocator, of course, and this one shadows declaration of body elsewhere. Sure, subheap allocator. How about that? Subheap allocator there, and this one here will be adapt body allocator subheap allocator. And of course we need to shove that subheap somewhere. So self.subheaps.append subheap. Sure. Does this take a pointer? Yes, it does. And of course, self dot. We should not forget about this. Total allocate memory. No, total free memory is expanded by memory.length. Because yeah, because why not? So this one is align constants dot arc constants dot default page size, and of course we need const arc is at import arc. Okay. So now this is problematic. We need these memory start, memory length of our body to be runtime defined. That means that we need to make quite a few changes to our body, and that's not something I'm prepared to do right now. This here should be okay. We should probably test that we are not doing anything too bad. Subheaps is initialized. Both of these live in our permanent allocator, which is okay. And yeah, that's pretty much all we need, to be honest. No, there are a few other things we need. So this one is extend, that basically takes in a slice of memory, but that's not the use we have for this. The use we have for this is extend by some length, some usize length. And that means that this now becomes a bit more involved, because we need to allocate pages or allocate a linear range. Okay, so that's fine. So let's go ahead and do that. So just after we allocate these two, just in case there is a problem with them, we are going to need to right, so here we are going to go for var memory is var memory will be allocate linear allocate pages. Yeah, and this here will be page count is at div exact. No, I don't think we need div exact. I think what we need is stud mem align backwards for usize or u64. Actually, I should probably not take usize here. u64 is fine. Address will be length, and the alignment is constants dot default page size. So that's the page count, and that means that this now allocate pages will take in page count at the very least. Probably this one needs to be tried. We don't have this function yet, but we are soon to have it. Let's create it over here. Actually, this will be a public function because we might have use for it. So allocate pages takes in self, which is a pointer to self, of course. Takes in a count, which is a U64 number of pages, and takes in arguments, which are struct of some things. For example, 0, which is a boolean, defaults to true. No, defaults to false. Yep. And this one here returns. So let's think about what this needs to return. This needs to return a many item pointer that's aligned to constants, rather to arc constants default page size of U8. I think would be a nice interface. Now. You know what? I'm just going to do something crazy here. Just going to do something like this. It's going to break everything we have, but it's going to be great. So, no, I don't care. So mem.body, memory, we don't really care. Wait, what is this? Yeah, never muted, that's fine. Mem.body, unused function parameter. Okay, that's fine. Right, so we want to do mem.pmem.allocate page. Hold on a minute. Why is this called allocate page? This allocate pages. Okay. 3 pages. Okay, so this one here, let's simplify things. This one here does not zero out the page. This asks us if we want this to be a committed page to allocate from, but does not zero out the page. That means that this can go, and the fix me with it. Great. Very cool. 3 pages to be done. Wow. Okay, so I have some more work to do, I guess. So allocate pages takes in count, takes in args, which are just going to be dot committed is args dot committed. Sure. Why not? This one returns an option to a page. That's kind of bad, isn't it? So if I find the range, I should just return the range. Otherwise, I should just error with an out of mem or something. Let me just take a look at this here. I should probably create a const error set for this, which is how do we go for errors? I guess something like this. Out of memory. Out of physical memory. Sure. Okay, so that this one now returns error. The error set for that. This one disappears. This one becomes const range is whatever that, and this one becomes const range whatever that is, since we just return whenever we find that. And this here basically is yeah, okay. Alright, that does look slightly better, I think. And do we have the same problem in vmem? Or do we not have allocate range? Allocate range. This one, we ensure that we always... Not really sure about that, brother. If we want this to work across different architectures, we are going to need to have an error set here out of vert memory. And replace this with a return error out of vert memory. Okay. Now this is kind of bad because now we can just do this and we can have page pointer. Can get rid of this. This now comes for free. And wait, what is this? Oh yeah, of course. Okay, so that's okay. I should probably have waited for a bit before doing that, but you know what? We live dangerously. So okay, that's fine. I guess that returns an error set that's unknown, but is there a way to... I think there is a way to basically concatenate error sets together. So is that like something like this? Other? Does that work? Wait, is it something like this? Not sure, but I think there was some way to concatenate error sets together. Maybe something like this. No, doesn't look like it. At least ZLS does not recognize that, but it's fine. That's fine. So now let's try this. This is our const vmem is whatever we put in here. We want this to be, hold on, let me just also add committed to be a boolean, which is false by default. Cool, very nice. So this one gives us a pmem range. So I should probably just write that down. The only problem I have with this is that we are returning a range, which is the item we get from this. This range here is not... hold on a minute. How did we create this range? Physical range list item that has a physical range in it. So the range itself is just copied out of the pointer. The pointer gets destroyed and we keep the range. So that means that the range is just a stack item. We don't need to free it here. Cool. Right, so now pmem, or rather, no, const vmem range is try mem.vmem.allocate range that has a length of, wait, is that length in pages or just length in bytes? what am I doing here? Just get pages. And then compute length to be count times arc constants default page size. This way we are sure to always be right. Yeah, all right, that's fine. So this again takes count. Wait. Oh, okay. Now this is kinda bad. Yeah, this might be kind of poopy. This might be kind of bad. And the reason for that is we have this virtual memory module, basically, that is the page map for the kernel and not something else or not anything else. But actually, I think can't we do something here? So we need an allocator and we need to register ranges and stuff like that on the virtual memory manager. And if I remember correctly, this is called somewhere here in init. And that means that here we have VMM is created just around here, and this returns it. Can we actually do something else? Can we do kernel vmem? Yeah, kernel vmm. Rather variable kernel vmm of type virtual memory manager, I think. No, of type vmem is undefined, and go down here and set kernel vmem to be vmem, and here just not return that. And of course this one would be public, and this one would be void. How about that? How bad is this? I think I'm breaking pretty much everything, but it's fine. It's for the greater good. So this one now becomes vmem.kernel vmem. This one becomes vmem.kernel vmem, and that's all there is to know for now. Right, so this one here takes in allocate range, takes in self.this, so that means that here I'm going to be obliged to do something like kernel heap, kernel vmm, that allocates that, and then here in the thing, I guess we can just leave it empty. Is it right? It is right. Okay. Cool. Now mem.vmem.mmap. This takes, so this needs to have that .mmap. So we want pmem range, vmem range, and flags, which are going to be mem.vmem.default mmap flags. Yeah, I don't really care about that. Does this, I think it fails because it tries to do allocation, so try that. And then return vmem range dot start. And I guess this one is a v address. So I guess we want to do first allocated range address is at bitcast of that, and this one here should know it's a U64, of course, and then we return at pointer cast of at pointer from int of allocated range address. What's your problem? Must have a known result type. Well, don't you know it's I guess we should probably remove the pointer cast. Yeah, that should suffice. Now, we haven't used self for anything. And why is that? Why is that? Is it probably because the kernel VMM should probably be passed to self? So virtual memory manager, which is a mem.vmem.virtual memory manager, a pointer to actually, and that means that here, instead of doing this, I could probably do something like so. That's I think slightly better. Physical pages are a shared resource, so that's fine. Virtual pages, though, are given per page map, so we can have as many of those as we want. So we should probably take care of that in our design. Right, so this one here, variable memory, and for now we are just going to do this one is memory, something like this, just to simulate that it's getting used, and to use this. There we go. Now, this is great progress. I think there is nothing that compiles at this exact instant. But yeah, we're going to survive. We are going to survive. Right, so here we are going to probably try to create a public function init, and in this init here, this of course returns a self, obviously. Do something like this, to return dot that, do that. So VMM, this will be VMM, should be taken from our inputs. Subheaps are fine, and that's all we need, I think. Yeah, we need that. So this one here needs VMM, which is a pointer to mem.vmem.virtual memory manager. And if I go to this one now becomes public, and actually no, what? That's not really what we wanted to do. It's vmem actually that we're looking for. Vmem, just rename that to something more sane. Vmem. And of course we have the same problem here, which is now this, so vmem, this now becomes public. Sure. And now I'm down in what I did here. Because now this is kind of useless because we would still want to create it somewhere here. So just reset this hunk here. Yeah. This needs a redesign. Yeah, not gonna lie, this needs a redesign now that we have enough hindsight to know what's good and what's bad. Alright, that's fine. So now let's go back to our main because we've broken a few things here. So where did we go? So var kernel vmem is now that. We don't care about that. We don't care about that. Now this one we care about, and then this one we care about. Cool. Now, somewhere around here, we are going to do so heap dot init takes kernel vmem, right? So that brings us to the list of files that needs to be compiled. Now this one here needs to change actually. So this one is vmem like so. So if args.0 we basically do at memset destination is probably should have this yeah, we should probably have this here before, but the way we are going to go about this is create a const allocated slice. And this one here would be this one here would be at pointer, no, actually allocated pointer, which is going to be a line arc page, constants default page size of u8. This one here is a pointer cast of or rather a int pointer from int of allocated address range address, which is fine. Now this now gives us the const allocated slice, which is a allocated pointer from 0 to count times arc constants default page size. Okay, that's actually fair. Let's keep this variable all the way down. So this one is allocated slice. You know what? I don't need this to be named. So instead, I'm just going to take that here. Oops. And do, we set it to 0. Right. And we return that allocated pointer. Else, so here where this is where the fun part starts. For now, I'm just going to do this, and I'm just going to do 0x AA BB CC TD 11223344. Yeah, that should be fine. So I'm just going to mark this as a fix. Fix me. We should figure out how to generate and splat a known predictable pattern, so that this gives us a way to know if we have crossed into memory that's not initialized. That's fine for now. So yeah, we need these three things added, and then we need to build to do on top of allocate pages, build a page allocator that basically has stdmem allocator, the stdmem allocator interface in it, and that does the pages allocation for other things that need that, especially if we want to start using arenas and whatnot in our kernel. Well, that was pretty much it for this one. We have reworked our general purpose allocator from the ground up again, because we are not afraid to throw away bad code. There are quite a few things that still need to be done, because every time we move forward, we need to take quite a few steps back in order to fix things that are just plain bad or overlooked. But that's the beauty of this type of project, and that's what I like about it. Anyway, as always, if you've liked this video, hit like, subscribe. If you have comments, remarks, or you just want to say hi, pop them into the comments section down below. And I'll see you next time. Fucking out.